Hi guys, my name is Andrea Ferroni and in this video I want to show you something different. This time we won't talk too much about theory, but I will show you something more practical. Again with software, with some theory, but we will see step by step how I realized this didgeridoo. If you have time, because this video is pretty long and we are starting from the end, so I already have my Didge in my hands, we will talk about the 1D acoustic simulation to calculate the right dimension of the internal part of this didgeridoo. We will also take care about the use of software to create 3D models, another software to create the routing of a CNC milling machine, all the phases, all the steps this machine needs to create a didgeridoo like this, and a testing. So if we match what we wanted to have. So what we wanted to have, or what I wanted to have, is a didgeridoo in D with the first tooth in F sharp and a second tooth in D. And this choice of the three notes was to create a didgeridoo that is in between a conical shape and a cylindrical shape. And this is very important because I wanted to obtain a very brilliant sound, so not too rough like an Hidaki, for example, but even not too brilliant and too synthetic sound like a plastic pipe or a plastic or a pipe from steel, for example. Please remind that the sound is not due to the material, but is due to the shape. So if you have a perfect cylindrical pipe, we will certainly obtain something that sounds like plastic. Not because it is plastic, but because plastic is one of the material you can find in cylindrical shape everywhere. And so we get used to listen that sound. And so the basic drum and the toots. And why I wanted to have a brilliant sound? Because I need less harmonics in the color tone of the didgeridoo, trying to emphasize the overtone line that I play. So when I play rhythm, I can recognize clearly these higher overtones. And in the meantime, I don't lose the simplicity I can have with conical shape playing the toots. Okay, so thank you very much. Enjoy this video and please try to watch this video till the end. At the end, I have some news for you could be interested in. Thank you. Okay, so as previously said, we are working to design the didgeridoo with the key of D and a first tooth in F sharp, that is the third major of the D scale. Maybe we will pay attention to have the second tooth that is tuned to a key. Maybe better if it is an important keynote of the D scale. So first of all, I suggest you to try several shapes and modifying it little by little. In this case, I prefer to use Didgeridoo, that is a software that is provided by Ben Gruer, a guy who lives in USA and at present I guess is working for Google, and is a software that I like quite much. So in this software it is important to start with, I usually work in millimeters, and the first number is the position of the mouthpiece. So the mouthpiece is at 0 millimeters of the length, and this software requires to write instead of the diameter the ray. So I prefer to have a bit larger diameter of the mouthpiece, so I change from 30 to 32 millimeters. For some other players, 32 millimeters probably sound very small, especially for guys, French players, I would say. It is even possible to make a larger didgeridoo, but in this case I really need that someone who asks me to make that kind of didgeridoo really knows what he is asking for. Otherwise, he risks to have a quite poor back pressure, especially compared to my usual didgeridoos. So 16 is the ray for 32 millimeters. And for a first simulation, I usually write the entire length of the didgeridoo. So in this case, I could say 1 meter and 55 centimeter. With a bell of about 70 millimeters, that is 35 millimeters ray. I click calculate and I obtain a result. So in this case I obtain 73 Hertz for the fundamental, and I can even read here the frequency of the third and the second tooth. Anyway, given that the shape is like this, so a pretty conical, but I should say a truncated cone shape, obviously the resonances are not tuned exactly what I need. So I have to go to Wikipedia and check for the right frequency I need. So in this case we want to have a didgeridoo tuned in D, the second octave of the piano, that is 73.4 Hertz. Then the first tooth that I want to have is 184.99 Hertz, that is F sharp, in the third octave of the piano. Then I can even try to find the second, to tune the second tooth in other frequency. A good frequency can be, again, maybe an important keynote. D, F sharp, A. These can be the keynotes that are pretty much important. I can also tune in other keys, but anyway, D can be a keynote that I can try to obtain. So I don't want to get you bored, so I show you immediately what I did. This try took me about 20 minutes. I wrote down several lengths and then several diameters. I obtained a shape like this. In this case, I just want you to notice the shape. The first part is pretty cylindrical, so at least for the first 80 centimeter, for example, and we have a not regular shape of the bell that is quite long, and the sort of bubble that you can see here about 98 centimeter far from the mouthpiece can be quite important. I used it to tune the tooths, but it is even important to create some inharmonic frequencies that usually are not appreciated in classical music, but for the didgeridoo it is very important to try to create a sound that sounds natural. Now I go back to the impedance and I see the frequencies. 73, 185 and 294. If I go back here, I can recognize that I was able to match the D at 73.4 and then F sharp at 185 and then again the D at 293.66. Very important. I do this try and I don't want to spend too much time to match exactly the cent of the hertz, even because this software do not take in account the damping. And I don't explain you the damping effect at present, but just think about that the damping is responsible to tune every resonance little by little lower than you see in this software. These vertical lines are the position of the natural harmonic. So as you can see, the basic drone that give a rise the sequence of the natural harmonic is obviously in the correct position. Then I have this resonance that is the third, so it's pretty in the middle between two harmonics, and then the second tooth is perfectly tuned to the third harmonic. It's a little bit higher, but since there is some damping effect, probably when I will finish the didgeridoo, this frequency will be probably a little bit lower than the frequency I'm looking to get. And so this is it. I also want to try these numbers with a software I already introduced to you that is called Didgeridoo. So now we change software and we try the same analysis with Didgeridoo. The last few things I want to tell you about this software, it is very nice because for those they have the knowledge to manage it, if you see the sound that the waveform of each harmonic, you can see where the standing wave are pumping. So in this case we can see this shape, and so the first harmonic, that is the fundamental, is pumping in this position. The first tooth or second harmonic is pumping in this position and in this position. Here you can see why I modified the shape exactly here. And then the second harmonic, the second tooth, that is the third harmonic, is pumping in this position, and in this position. Very important for those they have enough knowledge to manage this software. This is something that Didgeridoo does not have. But why I use Didgeridoo? Because probably you already seen the other videos. Didgeridoo gives you back some other informations. Perfect. So I'm here back, and as you can see, In this case, Didgeridoo prefers to work with meters, so I converted all the dimension in meters, and I also had to convert the ray in diameter for the second column. If I click Submit Geometry, I will obtain the same shape that I even want to see here again. So simply a different way to see the shape of the didgeridoo. And then I don't find information about pumpating standing wave inside of the pipe, but in this case I obtain again a good compliance between the frequencies I calculated before and right now. So I have the first frequency, the first resonance that is in D, then the second in F sharp, and then D again. I can even go downstairs to see how much is the error. So this software says that the F sharp is perfectly tuned, but the basic drone is 10 cents lower than expected, and the second tooth is 7 cents higher than expected. Anyway, a very small tuning has to be made maybe on a second try. So one didgeridoo has to be made, and then I can modify a fine tuning of it. And anyway, the both software do not take in account the damping effect. So this 7 cents higher probably will be even 10 cents lower. More important, this is why I usually do not use Didgeridoo, because if I only have the information above, I can create this other graphic just by experience. How can I do it? If I know that these are the frequencies, and in this software I see that, so they are not exactly coincidence, but very close. So if I have this resonance that is coincident with this one, this other frequency, this resonance that is coincident with this one, and so on, I can even check the other. So yeah, maybe Didgeridoo could even take in account the damping, because you see that F sharp here is lower, but I'm not sure. If you remember my previous video about Didgeridoo, sometimes you can expect very strange results. Anyway, for normal didgeridoo, as I told you, Didgeridoo is pretty good, and someone who want to tune the harmonics or resonances over the second, they have to study really a lot, and over the fourth or the fifth, it is very, very complex. So if you want, simply try it, but it is not so simple. Anyway, if I have this information right here, I can easily create this kind of shape, because as you can see here, we have D and A. They are positioned exactly where the natural harmonic are. So if I have resonances in D, F sharp, and D again, I also have to expect to have D here and A, that they are, give a rise simply while playing. I can't avoid to have them, absolutely. So it is not so simple to see this graphic and to imagine to recreate this graphic on the GIMP, because I can simply have a peak of frequency every time I have a natural
harmonic. You see that this is coincident with this one, this other with this line. C is coincident with this one. This is another nice tuning, because yeah, even this G probably, if we have some damping, probably could go closer to F sharp. They are very close to each other. As frequency, they do not look so close, but they absolutely are. So this shape can be very good. I'm really excited to try this shape with my new machine. And that's all. So this is, for those that didn't see my previous videos about Digimo, this is the sound spectrum of the tooth. This is the sound spectrum of the basic drone. This is the sound spectrum of the tooths. And these are the resonances. Okay, so I have to change software, and I have to take this dimension to design the internal part, especially of my new Didgeridoo, and the external part of my new Didgeridoo. The internal shape is very important. The external shape can be important for a very consumer Didgeridoo. They really need to have a very thin Didgeridoo or a very thick Didgeridoo. I do prefer to have quite thin Didgeridoo, but yeah, we'll see. This software is called Fusion 360. And it is a very nice software because it contains a lot of tricks to create a 3D model and to create a strategy to carve your Didgeridoo. And for those that are practice, it is even possible to make a simulation, model analysis, and maybe other simulations that I usually perform in my office, and so I never used this software to make model analysis and to see how things vibrate on this software. But the solutor seems similar to what I use in my office. Anyway, I open the page and I can decide in which plane I want to design, and given that I have to create a Didgeridoo, I have to create the external shape and then the internal shape. So the external shape is created with a rectangle, and it is 1 meter and 500 centimeter. And the diameter is 72 millimeters, but in this case I used the ray, and so I used up to change. So 46 is the ray plus the thickness. So the internal diameter of the bell is 72 millimeters, the ray is 36, and so 36 millimeters plus 10 millimeters thickness is 46, and this is it. Then I finish the drafting, and I have to select the profile that is already selected. I have to select the axis. I'm sorry because I have the Italian version, so for those they don't know Italian, this is the profile to be selected. I select the axis. I choose 180 degrees. I can see what is happening, and perfect. It is done. I click OK. And see you later. I just finish the Dig, and little by little with more sketches and with more rotation, and I will make you see the result of it. And so here it is. You can see here in the model tree that we have schizzo, that means sketch. And so I created some sketches to create every single shape. This cylindrical part, this truncated coined shape that you see. Then I also reduced, as soon as I finished the internal shape, I could reduce the thickness here, and especially here where I have to put my lips. The next step, I move from project or design, I don't know in English how it is written. Then I can choose other kind of solution here, and production. So I have to work the internal part first and then the external part. We start and I have to create a setup, and I have to choose which kind of machine I want to use. In this case I use a generic 3D axis CNC machine. Okay. Late machining, I don't care too much. I go very fast because I think you don't care too much about this topic. Then I have to work the internal part, so I move here where I can see the profile where the tool goes around to reduce the material, creating the shape. It is quite nice because you can see several icons, and in this case I would use this one. I have to decide which kind of tool to be used, and in this case I use a 16 millimeters with a round tip. Okay. Now it is making a simulation, so you can see the percentage of the job is running. So we have to wait for a while. Okay, it finished to create every step to work the internal part. I had to modify several options that I didn't do because it's 1/2 past midnight. So I just wanted to give you a short sample about what it's doing. I don't want the machine work this area at this time, so I will work to fix it, and I will finish the entire job and I will show you. The preview is here, so if I click here I can see the piece of wood that is simulated in green, and if I click play I can see how the machine is going to work, just to avoid several kind of troubles with the real machining. If I want to go faster, I can move like this, so we can see it from far, or I can continue clicking on the bar here. With a further software that is called Mac3, I can then open the files I saved from Fusion 360 that contains the information about the routing of the bits. For example, this file contains the information to make the small holes where I can insert plugs to join the two parts of the didgeridoo in the best way. So I avoid that the two shapes, but we will see later when I will glue it, they stay in position. So in this file that I can read here, you can find all the information the machine needs to make the holes. Then I also have other files that I prefer to run one by one, because anyway I have to stop the machine, the CNC, in order to change the beats. In this area you can see the position of the beat. Then the piece of wood is fixed on this table, where I made some signs, and I used again some wooden plugs like this one, so I can center the piece, avoiding to have a huge amount of wood that I will have to throw away or just to use it for fire. And so here it is. The first step is to flatten this upper part, and I will do it manually. Once the first operation is concluded, you can see the difference between how it was and how it is. So I already dismounted the first part in order to mount the second one. Maybe I can show you, where I will proceed with holes and the other operation. So the holes are now concluded, and this will help me to fix the didgeridoo when I will have to glue it, and even when I have to turn the piece to the other side to work the external part. And then I changed the bead. This was used for making the holes, and it is 5 millimeters diameter. And this is a ball nose, so it is round on the tip, and it is 16 millimeters as diameter. So I can work in the easiest way, faster, because it is important to make a nice didgeridoo, but it is even important to do not spend too much time just working the wood. Now the beat is changed, so I can run the last part of the program for the internal part of the didgeridoo. We will see. So this is how I put the plugs, and these are the reference point and the point where I put some screws to fix the piece to avoid that it moves while the machine is working. Okay, so now the machining is completed, and I just need to remove the fixing point and to remove a couple of screws that I used to fix completely the piece of wood to be worked. So in this way I was able to work all around, avoiding brackets and so on. So the next step will be painting and then gluing. This is how the two parts looks like, and the same plugs or grains that I used to fix the piece of wood on the table will be used to fix the two parts together. The two parts are now glued and varnished inside. I used 3 layers of varnish to varnish the internal part. This is to prevent cracks, first of all, but even because it will reduce the damping. So reducing the damping means that the keynote of this didgeridoo will be closer to what simulated, and even the highest frequency, the frequency of the overtone lines, will be more audible. So now I use the clamps to close the two parts. And I can use this kind of clamp that is very useful because you can use them with just one end. And then when it is fixed, I can use the normal clamps. They are more powerful. Even if I don't need to stress too much the wood, because the two shapes are so precise that they do not require a so huge amount of force. I spent years teaching people how to make didgeridoos, and I always recognize that they want to try their didgeridoo before it is completely fixed. Because, you know, it's something like you are making your own baby. Maybe it's a very extreme comparison, but this is it. So I want to try it. Okay, the mouthpiece has to be sanded, but the sound looks very close to what I want to obtain. I need some time that the glue can join correctly the two parts, and then we will see how the sound is.
So if you are still here, I promised you some news, and since this machine can work really a lot, and honestly I have a main job in acoustics for a quite huge company, so I don't have too much time, and I don't want to make mass production of didgeridoo. My intent is still to make research, and I'd like even to make research with you. For those that are practiced, maybe they can subscribe our association, and they continue to study their own designs, and we could cooperate. Maybe they can use this machine. I will help them to use it, because it needs weeks or months practicing and study every single software to create this kind of didgeridoo. So you can have my support to continue this kind of project. Or if you are a beginner and you want to study deeply the sound and how to create this kind of didgeridoo, it doesn't matter if you won't buy a CNC machine, but you will continue to make didgeridoos by chisels and an hammer. They are tools I always used, and is something that I continue to use. So in this case, I'm going to organize maybe 2 or 3 days workshop to have an entire program that is very deeply inside psychoacoustic and how to modify the shapes. Obviously, information that I still not published on the net, that maybe probably I will publish in the future. I don't know. It depends if I have time or not. I'm also writing a book about physics. So in case this workshop will start when the book will be published, a copy will be free for the guys who will take part in this association. But first of all, it's important to know that this kind of activities are under the organization of Arti e Tradizioni association that is based close to Turin, Italy. It is quite simple to arrive here, even if we are quite much in the country, but I will help you to arrive here. I will probably have other news, but at present I think this is a very important news, because it is not so simple to find this kind of machine, this kind of knowledge in the didgeridoo scene. And so if you want to cooperate or to learn, just send me a mail, or you will find even the WhatsApp on my website. So thank you very much for your patience, for your time. I hope you enjoyed this video. I'm excited because it is something new even for me. So thank you very much, and I hope to meet you in person. See you for the next video.